Happy New Year to you all. We are starting today with chapter 7, which is the first part of inferences. In chapter 1, 2, and 3, we learn about descriptive statistics, how to collect, organize, summarize, and present data. In chapter 4, 5, and 6, we learn about probability. We are moving now on to inferential statistics, in which we will want to make predictions, generalize results from samples to population, which is actually described as estimation and hypothesis testing. In chapter 7, we are going to learn about estimation, how to estimate a parameter given a statistics. Recall that a statistic is a measure from a sample, and a parameter is a measure from a population. In chapter 8, we are going to learn about hypothesis testing. We will skip chapter 9 and go to chapter 10 to learn about making predictions. In estimating a parameter, we have two methods. Either we use a statistic to make that estimation, and we call it a point estimate. For example, we can use the sample mean to estimate the population mean. We can also compute a range of values. For example, we can say that the sample mean is between 20 and 22. And this is called an interval estimate. A good estimator is unbiased, meaning that the expectation of its sampling distribution is the parameter. It is consistent, meaning that the larger the sample size, the closer the point estimate is to the parameter. It is relatively efficient, meaning that of all other estimators, it has the smallest variance. A good example of an estimator is the sample mean for the population mean, the sample variance for the population variance. So the confidence level in estimating an interval is the proportion of interval estimates from samples of the same size that will actually contain the parameter. So the confidence interval is an interval estimate which is computed using a confidence level. The difference between an estimate, a point estimate, and a parameter is called the sampling error. The maximum error of estimate is called the margin of error. If we have the maximum error of estimate, we can use it to compute the confidence interval. For example, for the mean, if you are given the margin of error E, we can use it by adding and subtracting it from the mean to get the confidence interval. So to compute the margin of error, we are going to deal with two cases. In the first case, sigma is known, and on the second case, sigma is unknown. So if the population is normally distributed or the sample size is large enough, that is at least 30, when sigma is known, the margin of error is equal to Z alpha over 2 times sigma over square root of n, where Z alpha over 2 is generally 1.65 for a 90% confidence level, 1.96 for a 95% confidence level, 2.33 for a 98% confidence level, and 2.58 for a 99% confidence level. So actually, this value of Z alpha over 2 is the value Z, so that the area between minus Z and Z is the confidence level. You can always use that method to find the value Z alpha over 2, which will be later on called the critical value. If you have a confidence level, to find the critical value Z alpha over 2, think about Z so that the area between minus Z and Z is the confidence level. I've given you here the value of Z alpha over 2 for commonly used confidence level. Example. A researcher wishes to estimate the number of days it takes an automobile dealer to sell a Chevrolet Aveo. A sample of 50 cars had a mean time on the dealer's lot of 54 days. Assume the population standard deviation is 6 days. Find the best point estimate of the population mean and the 95% confidence interval of the population mean. As I said before, the best point estimate for the population mean is a sample mean. So here it is 54 days. For a 95% confidence level, Z alpha over 2 is 1.96. So we are going to use this and fit it into the margin of error formula, E equals to Z alpha over 2 times sigma over square root of n. That is 1.96 times 6 over square root of 50 equals to 1.7. The margin of error is 1.7, as we can see from this formula. So we will subtract it from the mean and add it to the mean to find the minimum and maximum value of the confidence interval. And so, as you can see it here, you do 54 minus 1.7, 54 plus 1.7, and we get the number of days is approximately between 52 and 56 days for a 95% confidence interval. You could also use your calculator for those of you with a TI-83, 84 calculator. You will go to Start, then Test, and go to number 7, option 7 for Z interval. Because we have the statistics here, that is, we are given the mean and the standard deviation. Sigma is known to be 6. The sample mean is 54. The sample size is 50. The confidence level is 0.95. And then we calculate. That will give us the confidence interval. You don't need to round it up, so you can leave it as 52.3 to 55.7. But we know that by saying 52 to 56, we are still correct because there is no half day here. Can do another example. A survey of 30 adults found that the mean age of a person's primary vehicle is 5.6 years. Assuming the standard deviation of the population is 0.8 year, find the best point estimate of the population mean and the 99% confidence interval of the population mean. Here, sigma is known to be 0.8. The sample size is 30. The sample size is 30, not 50. and the confidence level is 99%. So using a calculator, you can go to Start, option 7, and we have standard deviation 0.8, sample mean 5.6, sample size 30, confidence level 0.99, and compute. Or you use this formula. Make sure that you make the correction here is not 50, here is 30. And you will get 5.6 Z alpha over 2 for 99%, remember, was 2.58. You can always go back. You can always go back to that table here. For 99%, 2.58. This is where you get the Z alpha over 2. So we will find the confidence level. The confidence interval is 5.2 to 6. It's actually 5.97. We round it up to 6. Sometimes we are interested to determine the minimum sample size for a given margin of error. That is, the researcher is interested in knowing the number of individuals to be included in the research to achieve a certain margin of error, a maximum error of estimate. So the formula here is n equal to Z alpha over 2 times sigma over E squared. Example, a scientist wishes to estimate the average depth of a river. He wants to be 99% confident that the estimate is accurate within 2 feet. So the margin of error is 2. From a previous study, the standard deviation of the depth measure was 4.38. We will use that as sigma because it is from previous studies. So here we have margin of error equals to 2. Confidence level for 99%, Z alpha over 2 is 2.58, and the standard deviation is 5.8, which we put into the formula to get 31.92. And the number of people, the number of individuals is 32. Always round it up to the next whole number. Even if you have 31.1, round it up to 32. Now, if sigma is unknown, we will need another type of distribution, which is called the t-distribution. And for the t-distribution, we will use T alpha over 2. The t-distribution is the value taken from the student t-distribution table with a degree of freedom equals to n minus 1 for the mean. The t-distribution is bell-shaped and symmetric about the mean. Like the z-distribution, the mean, the median, and the mode are all equal. And the curve never touches the x-axis, but the standard deviation is not 1. Actually, the variance of the t-distribution is greater than 1. And it is a family of curves, so it depends on degrees of freedom. As the sample size of a t-distribution increases, the distribution gets close to the z-distribution. Those are the properties of the t-distribution. The symbol df stands for degree of freedom, which is n minus 1. We use the t-distribution to compute the margin of error of E when the population is normally distributed and the sample size is large enough. When sigma is unknown, we use S in place of sigma, and instead of the Z distribution, we use the T distribution to get the formula for the margin of error as it is here. T alpha over 2, S over square root of n. So to find the confidence interval, you subtract the margin of error from the mean added to the mean as we did for the Z distribution. An example of how to find the T alpha over 2. So we are discussing at this point the T distribution. The T distribution table is in your textbook. Some of you have it as in a formula sheet, or you can find it in the textbook towards the end, the appendix, page 600 and in page 652 of your textbook, you'll find the T distribution. It is useful to determine the critical value T alpha over 2. So, for example, if the confidence level is 95% and the sample size is 22, the degree of freedom is n-1, so it is 21. For confidence interval 95%, you will match the degree of freedom of 21 to the confidence level to read the T alpha over 2, which is 2.08 here. So for your homework, you will have questions about finding T alpha over 2 for a given confidence level and sample size. Always remember that the sample size is used to find the degree of freedom, which is n-1. Let's look at an example. 10 randomly selected people were asked how long they slept at night. The mean time was 7.1 hours and the standard deviation was 0.78 hours. Find the 95% confidence interval of the mean time. Assume the variable is normally distributed. Here we are given the sample mean 7.1 and the sample standard deviation 0.78. So the population standard deviation is not given. We will need to use the T distribution. In order to use the T distribution, we need the degree of freedom. For 10, the degree of freedom is 9. So if you open your textbook to page 652, on page 652, you will go to degree of freedom of 9 and match it to the confidence level of 95% to find 2.262. So we will fit it into this formula. X bar is 7.1, T alpha over 2 is 2.262, S is 0.78, N is 10, and we replace it in the formula to find the confidence level, the confidence interval. For those of you having a calculator, you go to Start, then Test, and option 8, T interval. We are going to use statistic. If we were given data value, we will use data. We are going to use statistic. Here, the sample mean is 7.1. The sample standard deviation is 0.78. The sample size is 10. Confidence level in this case is 0.95. Then we calculate. So we will have a confidence interval of 6.54 to 7.66. Let's do another example. The data here represent a sample of the number of homes fires started by candles for the past several years. Find the 99% confidence interval for the mean number of home fires started by candles each year. Here we have data. We can use a TI-83 calculator or any other mean to find the mean, the standard deviation. But if you have a TI-8384 calculator, you can use it. You can use it by going to Start, Edit, we go to Start and then Edit and enter this value into L1. If you don't have a TI-83 calculator, you can use the statistic in Excel, descriptive statistic, to find the mean and the standard deviation. So if you go to Excel, you enter these values into column A, and then go to Data, Data Analysis, Descriptive Statistics, and you will do a summary statistics to get the mean and the standard deviation. The mean here is 7041.4, 7041.4, and the standard deviation 1610.3. We need these values to compute the confidence interval. In the formula for the confidence interval, recall that we want to find T alpha over 2. For a 99% confidence level, we need to identify the sample size, which is 7 here, and the degree of freedom will be 7 minus 1, which is 6. You go to page 652. Under degree of freedom 6, we are looking for 99%. We match it, degree of freedom 6 to 99% is 3.707. These are the three numbers that we need: the mean, the standard deviation, and the critical value T alpha over 2, of course, with the sample size. We are going to fit these values into the formula. And at the same time, for those who have a TI-8384 calculator, it said you enter the data into L1, then come back to your calculator, press Start, and go to option 8. Now we have data, so we will click Data and choose L1 because we are using line 1. The confidence level here is 0.99, and we calculate. We give you 47.85.92, 47.85 and 92.97. So we have this confidence interval for the number of home fires started by candles. The average number of home fires started by candle is between 4,785 and 9,298. Now for proportion, we want to record here, it is important at this point for you to know what is a proportion. The proportion is obtained by dividing the number of success by the sample size. Sample proportion is X over N, P hat, and Q hat is N minus X over N. Observe that Q hat equals to 1 minus P hat. In some of your homework and quizzes, you will be asked to find the sample proportion. It's just to take the number of success divided by the sample size. In a recent survey of 150 households, 54 had central air conditioning. Find P hat and Q hat. So P hat will be 54 over 150, which is 0.36, and Q hat is 1 minus P hat, which is 0.64. To find the confidence interval for sample proportion. The formula is p hat minus z alpha over 2. Remember z alpha over 2 from the table we had in 7.1, section 7.1. For 90% is 1.65. For 95% is 1.96. For 98% is 2.33. And for 99% is 2.58. We use the z distribution when NP is greater than or equal to 5 and NQ is greater than or equal to 5. That is both number of success and number of failure, both those who are in the characteristic and those who are not, is greater than or equal to 5. So a sample of 500 nursing applications included 60 from men. Find the 90% confidence interval of the true proportion of men who applied to the nursing program. First, we want to find the sample proportion, which is x over n. N here is 500, x is 60, so we have 0.12, and q hat is 0.88. For a 90% confidence level, z alpha over 2 is 1.65. So we replace it into the formula to get 0.96 less than or equal to p, less than or equal to 0.14. So that means we are 90% confident that the percentage of applicants who are men is between 9.6% and 14.4%. Another example, a survey of 1,721 people found that 15.9% of individuals purchase religious books at a Christian bookstore. Find a 95% confidence interval of the true proportion of people who purchase their religious books at a Christian bookstore. So here we already have the sample proportion is 15.9%, which is 0.159. We subtract it from 1 to get Q hat, which we will fit into the formula here. We can also use our calculator. To use calculator here, you want to find the number of success because you were given the proportion of success is 15.9. So we will do 1,721 times 0.159 will give us approximately 274. That is X, the number of success. We can now go to start and then choose test. We will go down to 1 proportion Z interval. 1 proportion Z interval is at letter A. We have the sample size is 1721, 274. Confidence level here is 0.95, and we calculate. So you fit this into the formula and you will have 0.142 and 0.176. So you can say with 95% confidence that the true percentage is between 14.2 and 17.6. As we did for the mean, when we are using the z-distribution, we can compute the minimum sample size for proportion. The formula for the minimum sample size is n equals to pq times z alpha over 2 divided by e squared. Here we will have two cases. And the first case is when a sample proportion is given. When a sample proportion is given, we use it to find the minimum sample size. Example, a researcher wishes to estimate with 95% confidence the proportion of people who own a home computer. A previous study shows that 40% of those interviewed had a computer at home. So this 40% will be our P, and Q will be 1 minus 0.4. A researcher wishes to be accurate within 2%, so the margin of error is 2%, which is 0.02. So with 95% confidence level, Z alpha over 2 is 1.96. We fit it into this formula to get that the researcher should interview a sample of at least 2,305 people. That is 2,2305. In some cases, a sample proportion might not be given. In this case, we are going to use 0.5 for P and Q. In this example, the researcher wishes to estimate the proportion of executives who own a car phone. She wants to be 90% confident and be accurate within 5%. Accurate within 5% will mean the margin of error is E equals to 0.05. So into this formula, we will take P and Q to be both 0.5, which we replace into the formula. For a 90% confidence level, Z alpha over 2 is 1.65, E is 0.05, and we get 272.25 that we round up to 773. Confidence interval for variance and standard deviation. So we may want to find the confidence interval for variance and standard deviation. In this case, we will use a distribution which is called a chi-square distribution. A chi-square distribution is a non-negative distribution which is skewed to the right. It depends on degrees of freedom, which is for the variance and standard deviation n-1. So as you can see, these are several chi-square distributions for some degree of freedom. So the distribution is skewed to the right, but as the sample size increases, it tend to become a normal distribution. So these are the formula for the confidence interval for the variance. You will usually be given the sample size. From it, you will get n-1, the sample variance. So what we want to learn how to compute here is the chi-square left and chi-square right. To find these values, you need your book at this point, your textbook, to find the distribution. The distribution, the chi-square distribution in your textbook is in page 653. So how to find chi-square left and chi-square right? Let's go to page 653 of your textbook and use it to find the chi-square right and chi-square left for a 90% confidence interval when n equals to 25. This is the procedure. To find chi-square left, chi-square right, given the confidence level, subtract the confidence level from 1. In this case, we will subtract 0.9 from 1 to get 0.1. We will divide it by 2 to get 0.05. Then we will subtract 0.05 from 1 to get 0.95. So for 90%, we will need two values here. We will need 0.05, and 0.95. You go to your table. The sample size here is 25, so the degree of freedom is 24. And you are looking for 0.95 to get chi-square left, which is 13.848. Still under 24, you go to 0.05, 0.05 to get 36.415. So this is what you will see on your table. Under the degree of freedom of 24, you will first get 0.95. That is kind of midway between 90 and 100, 0.95, and then 0.05, which is 100 minus 95, essentially. With the degree of freedom of 24, you get these two chi-square. One is to the left, we call it chi-square left, and the other one to the right, we call it chi-square right. Once you have these two values, you can compute the confidence interval for the variance. And once you have the confidence interval for the variance, take the square root of both numbers to get the confidence interval for the standard deviation. Example, find a 95% confidence interval for the variance and standard deviation of the nicotine content of cigarettes manufactured in a sample of 20 cigarettes if a sample of 20 cigarettes has a standard deviation of 1.6. So the sample size here is 20, and the standard deviation is 1.5. What we need is to find chi-square left and chi-square right. Confidence level is 95%. The midway between 100 and 95 is 97.5. You can just obtain that by doing 1 minus 0.95 divided by 2, you will get 0.025. Then subtract it from 1, you get 0.0975. Those two numbers now will be used to find the critical values. So go to your table with a degree of freedom of 19, because the sample size is 20. First, we are looking for 0.975, and we will get 8.907. Under 0.975, degree of freedom of 19, you have chi-square left, 8.907. And under 0.025, degree of freedom of 19, you will get 32.852. So the degree of freedom of 19 times the standard deviation square divided by chi-square right, 32.852. We will get a confidence interval for the variance as 1.5 less than sigma square less than 5.5. Taking the square root of both sides, we will give us 1.2 less than sigma less than 2.3. You can be 95% confident that the true standard deviation is between 1.2 and 2.3 milligrams. So find the 90% confidence interval for the variance and standard deviation for the price in dollars of an adult single-day Sky's Lift ticket. The data represent a selected sample of nationwide Sky results. Assume the variable is normally distributed. At this point, we are going to use Excel to find. We use Excel to find the sample variance. So in column A, I will enter the data values 59, 54, 53, 52, 51, 39, 49, 46, 49, 48. This is what you will do if you are using the T distribution and you are given the data. You enter it in Excel here and go to data, then data analysis, descriptive statistics. This is the data runs from A1 to A10. A1 to A10. I will choose C2 here, where I want the value to come, and I will check summary statistics. We did this in chapter 3. It is going to provide us with the sample standard deviation, which is here 5.31. The sample standard deviation is 5.31. I will go back to the PowerPoint. So the standard deviation was 5.31. To find the variance, we square the standard deviation to get 28 point, let's say roughly 28.2. So this is what we need. Sample size is 10, n minus 1 is 9, the degree of freedom. Confidence level 90, we will choose 95 and 0.05, 0.95 and 0.05. By now, you should be used to the two values that we need to find chi-square left and chi-square right. So at 90%, we have 10% divided by 2, 5%, subtract from 1 or 100, you have 95. So we are going to be looking for 0.95 and 0.05 with degree of freedom of 9. Degree of freedom of 9 for 0.95, we get 3.325 to the left. And to the right, we will get 16.919. Those are the numbers that we need to fit into the calculator. And in some of your quizzes or homework, you will be asked to find chi-square left, chi-square right as a quotient, standing alone quotient. So we will replace those values into the formula here. And we will get 15 less than 6 mass square less than 76.3. Taking the square root, we get 3.87 and 8.73. So you can be 95% confident that the true standard deviation is between 3.87 and 8.73. So you can do your homework, and I want to remind you again here, as you observe on your homework for chapter 6, most of you had the wrong habit of just writing the answers. So if you are asked, what is the area to the right of z equal to 0.37, the answer that is good for me is the area to the right of z equal to 1.93 is. Don't just write the number 0.2135. It doesn't make sense that you have homework which is made of number 1, 0.37, number 2, 72, number 3. No, you will not get a full mark. You will get points. If you will do that for all your questions, you will get 0.7. If for some of your questions you are writing, and for some you are not writing, depending on how much, you can get 0.8 or 0.9. But if in most of your question you express, you don't have to express in all. Some of it you might, you don't really need to write much. You just need to tell me what that answer is for, and then you will get the full mark. So I want to be strict with that because I do not want you to just copy the answers from somewhere, just the numbers. You might not have copied, but I have no evidence that you didn't. Even if you are copying, you want to write what the answer to your question is. We still have chapter 7, chapter 8, and chapter 10, and I want you to have the full mark for those homework. I'm not asking you to write any much computation. I want that if somebody sees your answer, the person can be able to tell what that number means. Okay, once more, Happy New Year and be safe.